welcome back everybody. This will be our 8th video here. It's a Saturday morning. I think it's December 3rd, and we're going to get some more work done on this amplifier. I think this is part 8 at this point in time, and this will either be the last one or the next to the last in this series. But a couple things yesterday in the video I had made in part 7. I had mentioned that I felt this board needed to be grounded, and I was going to shoot an email off to Sheldon Stokes, the guy who originally designed this board. And he was super nice. Sent me an email back last night, and he basically said, "Yep, you're right. That side should be grounded." And so I'm actually going to tie one from here on the ground back to this spot here where we've been grounding everything else. That way we kind of got our common ground point for just about everything. So we'll do that here. And I also had 2 pieces of feedback from let me see if I can show you here, from some viewers online, and one of them I actually agree with. So I was kind of following this schematic here where they were kind of showing you to, on a 3-prong to ground one to lug, to bring the white over here and then take the black over here through the power switch, and that's exactly what I did, if you'll notice here. However, I will tell you that a viewer pointed out to me, and for US specs, you should really ground the hot wire, not the neutral. So the white wire is always neutral in the US, and we're actually grounding neutral. I would say for 99% of the scenarios, you're just fine grounding the neutral wire. In other words, if this transformer shorted or something, it would still blow this fuse and not cause damage to your wiring upstream, etc. However, there is a scenario where maybe like this something would get shorted in the amp, and this hot wire here, let's say this hot wire here got shorted to chassis. You could still get shocked by touching chassis, and may or may not blow this fuse with it being on the neutral side. In other words, you could just be lighting up the chassis. It would take a certain special scenario for that type of thing to happen, but they're right. So I'm going to swap put the white wire up here, and I'm going to move the neutral wire up here, and I'm going to move the hot wire down here to the fuse. And put that in place. The other one was, someone pointed out to me, hey, you missed a nut here, right down here on top of this. And actually, I didn't miss the nut. There's really not enough room for the nut right here on this side. And this thing is locked down solid. As you can see, when I move it, the entire amplifier moves. And the fact that it doesn't hold ground, and the board is down over top of the bolt there, I'm not going to put one on that side. I think I risked too much getting it too close here to the speaker wire, the hot speaker wire, 8 on tap, to drop one down in there. So I intentionally had done that, but that board's in there good and solid, and it's not going anywhere. So, alright, up next we're going to get this thing resoldered here. Going to get that ground wire ran from the ground strip side of this thing over to here, and then I do want to go back through the SDS Labs, the actual instructions here for, let me zoom back out here, for the preamp board here, and make sure, because there's some settings and whatnot. I just want to make sure I really understand this board really well before powering everything up. But hang tight, we'll be powering this thing up in just a few minutes. Okay, as you can see now, I've got the black wire here coming out of the power cord that's going into the fuse holder. So we're now fusing the hot wire. We got the white wire now going over to the thermistor, feeding around, etc. I've also ran a ground wire here from this side of the strip right over here to this ground lug. So we're good and grounded at this point, and I think I'm ready to power this thing up. I'm going to do something. I'm going to get the fuse in it. I'm going to read the book here and see what size fuse it takes, and it should tell me that. 3 amp fuse, and we're going to throw that in. Let's see if it says, okay. We got a 3 amp fuse put in here, and get this thing. I'm going to first power it up without any tubes in it, and then just to make sure there's no shorts in in the electrical wiring here, or maybe straight into the transformer. And then we're going to bring it up with the actual tubes in it and see how this thing comes up. Okay, we've got it plugged into the variac at this point. I've got the variac turned on up around 25-30 volts, and let me slide it over this way just a little bit, and I'm going to throw a voltmeter down here. I've got this thing on AC volts, and I'm going to hit the power switch here. And so over here it says I've got 42 volts right now, and you know, no sparks. I'm going to check here just across this I'm sorry, where the filament windings are, and if you'll notice, we're getting what is it saying here? Get on there, about 2.38 volts. That's good. Remember, this will be 6-volt windings when we're completely up there. But what it's telling me is that there's voltage coming out the AC side of this thing. Similarly, I should be able to get some AC voltage out right here and right here. Oops. And I'm getting 1.8 volts AC right there, and that's the 5-volt filament windings. So let's turn this thing on up a little bit more. That puts it up to about 60 volts right there, and we should scale accordingly. 3.4 volts now on the get that a little bit out of the light so you can see it. Yeah, 3.4 volts there, and similarly this should scale up. Yeah, we're getting 2.7 volts there. We'll keep taking it on up to about 80 volts, and so far no sparks are flying. Good, we're getting up to the 4-volt range. Coming out this side here, this will be interesting. We've got 530 volts there on the high voltage winding, so this thing's cranking up quite well. I'm going to take it on up now to about 90 volts. Let it sit a minute, and then we'll take it all the way up to 110 volts right there. So you know, at 110 volts here, no load, no 750 volts right there on the output. And we're sitting here at 6.2 volts on the filaments. So looking good so far. I'm going to turn it off at this point, turn the variac off. I'm going to bring it up the same way again. I'll crank it back down to about 30 volts or so and get the tubes in it and bring it up and just make sure everything comes up safely. Okay, and let's talk a little bit about the tube complement. We ordered some new tubes for the output and the rectifier, but the preamp board, they called for 12 AU7s, and I told the customer, I said, I've got thousands of 12 AU7s. And so I went through and I picked out a brand new set of 4 5814s. I had quite a few sleeves of these, so I went through and I matched 4 of them. So we've got you know, a matched quad of 5814s, new old stock in the box right here that we're going to put in this thing. They'll end up using two in each amplifier. We ordered a matched quad of KT88 Gold Lions. These are the newer reissues. Believe it or not, made in Russia, but still really, really nice, beautiful looking tubes here. And I've used these in quite a few things, and they just turn out great. I mean, I think the craftsmanship and quality is as good as anything that's ever been made, to be honest. It's a debatable topic. I know a lot of people tell me otherwise, but that's what I believe. Same thing. These Tube Amp Doctor this is a GZ34-STR, which is their selected tubes. These things run great. I'm running them. I'm running one right now on an amplifier I've got over here. I think you you know, the good old Mullers or Amperex GZ34s are rock solid. Some of the stuff made in the the 90s, 2000s, not so much, but I think this is pretty good quality stuff. So let's get these things put in and turned on. All right, you can see them here. They're mounted in there now at this point. Looking good. This amplifier has got quite the beefy look to it with those KT88s in it, but I'm going to flip it upside down to turn it on just to make sure. And I'll probably put it on its side, honestly, like this. That way I can watch the bottom at the same time as I can look at the filaments lighting up on these things and make sure everything's looking good. So hold tight and let me get it situated, get these other tubes off the bench here, and we'll get this thing powered up. Okay, before I powered this thing up with the tubes in it, I just wanted to walk back through this whole thing one more time to make sure I didn't miss anything. And I was digging back through the paperwork here, so I can zoom in on the part that where it talks about it right here. But it's basically saying here the ground lug of number 11 on this board. There should be 2 wires, one to the outer shell of the input jack and one going to ground. And I missed that originally. Honestly should have known that, because the board's got to have some ground somewhere. Much like this board, it didn't. These screws here don't actually ground this board. So I've got to run a wire from number 11 here over to this common ground spot that I'm using right here. So let me zoom back out next to you. Got to go from number 11 right here over to this common ground spot. So out with the purple and black wire again. We're going to get that ran, and I have double checked, triple checked at this point. That is the only thing missing, but I always like to do a really good double check on everything, because it is so easy to overlook something like that. We'll be right back after we get it soldered in. Okay, ground wire is ran from number 11 over here around and soldered well into this common ground point right here. I think we are good to go at this point. Let me get everything set up here and we'll turn this thing on. Okay, at this point you can see we've got a couple things going on here. We've got an input jack in here that is running up this cord and goes up into the B&K 4003A function generator. I've got it set at a really light input of about 0.1 volts right now, with a 1 kilohertz tone going into it. We got the output here feeding up through our our switch setup into the dummy load. Got the oscilloscope on right now, and we've got the power switch here off. I'm going to turn the variac on. And the reason I've got this thing mounted upwards like this right now, I've got this this slug here on the voltmeter connected to, let me get this where you can actually see it, connected to ground, and the other lead here, as you can see right here, I have it plugged into the 1.56 volt socket. So I want to make sure that once we get this thing up to 110 volts, that the bias right here, potentiometer, has that thing at 1.56 volts. I don't want that being way off. So let's go ahead and flip the switch on down here, and now I'm going to hit the power here, and I'm sitting at 41 volts. Make sure the speaker's on. Yep. And it's just quiet sitting here at 41 volts. Nothing going on, no smoke, no sparks. Let's go ahead and bring it up to about 50. It's about 51 volts right there. Still no sound. It's alright, we're going to go ahead and bring it on up to about 60 volts. That's 60.5 volts right there. Still no sound at this point. Alright, we will bring it on up to 71.3 volts right there. At this point, still nothing. See if I can see any filaments starting to light up over here. Nothing yet. Oh, listen. faintly. Let me turn the input drive up a little bit. Faintly, faintly, just a little bit of sound there. Let me take it on up to, that's about 85 volts right there. And I wish you could see it on the oscilloscope. I've now got a smooth, clean sine wave. I did not have that. Let's see if I can superimpose a video on top here. Yeah, you can see the nice clean sine wave. Down at 50 or so volts when it first came on, we weren't getting this nice clean sine wave like that. And you can kind of see my setup here on top. Alright, we're now up to 94 volts right there. And if you'll notice, we're at 1.0 volts right along in here. Still nice clean sine wave. I'm going to take it up to, that's at 101.5 volts right there. Still nice clean sine wave on the, and I've got that sitting at about 112 volts right there, which is pretty common, anywhere between 110 and 120 volts for common line. I'm going to kill just the speaker. I'm going in the dummy load right now. If you notice there, I'm getting about 1.4, 1.5 volts. Now, what I am going to want to do is kill the drive input. So I just killed the signal generator, because when I set this bias, I'll basically want to do it at a quiescent spot with no signal going into the amplifier, if that makes sense. And somewhere here I have lost my screwdriver. There it is. So we're at 1.46 volts right there. Let's turn this thing. 1.48, 1.5, 2, 3, 4, 5, and 6. That's about as close as you're going to get it. It's bouncing right around it there. Rock solid, rock on. Let's do this. Let's and that thing's bouncing a little bit just because I got a loose connection here as I plug this thing in. Let's let it warm up just a little more, and I want to check the bias again because it may still keep climbing over time. And you can still hear. Oh, I killed the input. Turn the input drive back on. You can still hear there. Sounds good. Let's do this just for kicks and giggles. I'll let you watch it on this superimposed video. Okay, you see nice clean audio right there. I'm going to take it over to a triangle wave. Wow, nice sharp edges, getting good clean triangle wave. We'll take it over to a square wave. A little bit of rounding there on the corners, but nothing bad at 1 kilohertz. As I take that on up, it's not bad at all. There's no overshoot on that. Completely happy. I'm going to move it off of this over onto the turn on the generator here. Let's plug this in. Let's go with amplitude 0.3 volts. We're driving this thing now pretty hard, and let's see what we're getting. We're sitting at 0.3% distortion right now, so wow, that's nice. And you can see I'm driving the heck out of this thing now. I have to bring it way back down here, but okay, hang tight. Alright, now what I want to do, and as you can see as this thing's warmed up, oh actually because I'm driving it harder, amplitude 0.1 volts, I bet it'll go back down, yeah it does. And if I turn the source off altogether, let's see what it's down at. 1.6, so it is drifted up a little bit as this amp is warmed up some. You want to at least let it run a few minutes and get warmed up before you go setting bias on it. So let's take that back down to 1.56. I think that's pretty close right in there. It's bouncing right around the 1.5 something to 1.6 something. So yeah, let's do a couple things. One, let's hook up some music to it and see how this thing sounds. Hang on one second, I'll be right back. Alright, the bias staying on track at this point. Got my little MP3 player here. Let's see how this thing sounds. Oh wow.
Call me on the telephone. Don't have the heart to leave it alone. Don't believe a single word you speak. I'm fine dining with some lions and thieves.
Thing sounds amazing. Alright, up next we're going to get some specs off of this thing, and so I may move the camera around a little bit on that. Let's see what we get. Okay, driving the amp pretty hard at this point in time. You see a nice clean sine wave here. If I hit the distortion button here, cranking in, driving really hard, still at 0.4% distortion. Kind of take a look over here on this HPA 3582 spectrum analyzer. One nice little clean blip at 1 kilohertz. The next little blip over here, which is right there, is so far down the scale it can't even really be measured. So no harmonic issues whatsoever. If I flip this thing over to hang on, check this out. I'll move it up to the other unit with a square wave in, and you can see more and more blips here when you got a square wave running. Just click back to a sine wave, and it's just one nice little input signal there. So okay, nice and clean, beautiful. Let's run some sweeps on this thing. Okay, what we've got here is frequency response plot connected to the 8903 frequency or audio analyzer. Thanks to Pete Millett for this software. It's free and he's a top-notch guy. At any rate, got it hooked up at this point. What we're going to do is click start. It's going to come back. We're basically asking if the reference level is okay, 18.72, and we're going to run this thing. See what we get. So I've got it on a dummy load so you don't hear the thing in the background, mainly because I wanted a non-resistive load, and you can see it plotting across here right now. Frequency response, you know, below I would say 100 hertz you're down, what is that, 0.2 or 3 dB right here, and then all the way over here as you get to 20 kilohertz where this test maxed out at, you're down about 0.8 dB, something like that. Or actually it says right here 0.56 dB. So wow, looks super flat, beautiful frequency response. Couldn't be any happier. Okay, we were able to run a frequency response sweep, which turned out really good. You'll get to see it, or you've probably already seen it at this point in the video, but couldn't get my %THD program to work properly, so I'm going to do it manually over here. So 1 kilohertz, driving it at 0.3 volts. We're at 2.2% distortion right now. If I say frequency 4,000 hertz, you'll notice we're still at 0.2. Frequency 9,000 hertz. So I'm kind of manually doing the sweep. You know, we're at 0.3% distortion. Frequency Let's go to 14,000, which is beyond our ears, and we're still at less than 0.5% distortion. So this thing's looking great across the spectrum all the way down. Oh, let's go way down low. Frequency 100 hertz. We're getting here. Listen, 0.3%. Let's go frequency 40 hertz. You can vibrate in the whole room, and still 0.4%. Frequency 20 hertz. Listen to this. It's just a flutter, and we're still at 0.6% distortion. So if I could have got the sweep to do that, the software, it would have been a little nicer, but you get the gist all the way across the spectrum. This thing's running super quiet at this point in time. I'm going to get it off the bench now because I'm totally happy with the specs. One thing I'm really happy with, the transformers, cool as can be. No heat to them whatsoever. Lots of heat coming off right there. Those KT88s put a little bit of heat. Got one or two things I want to do left of this one. We're going to call it wrapped up and finished. So really happy with the specs on this thing at this point. Alright, I went digging down in the barn, and I had picked these up at a ham fest. I think I paid $4 or $5 a piece for them. Still brand new in the box, new old stock. You know, electrolytics. These were all. This is a 40-40-20-20, all at 450 volts. Don't know what I would ever use them for. I probably wouldn't, because they're new old stock. They're just as old as the ones that were in this thing. But what's beautiful, look, brand new shiny cans, no stickers, no labels. Check out what we're going to do here. We're going to end up dropping one of these puppies right down in there, and I'll go underneath and twist the caps, and then you got an all original looking unit with a nice shiny electrolytic there, the way this thing would have looked coming from the factory. Okay, at this point we polished up the top plate. Love the looks of those KT88s in there. This thing's looking really good. Got that got the capacitor here mounted and twist locked underneath. It's in there good and solid. Looks like a factory original there. Let's put a cage on it. Okay, got the cover on this thing. Personally, I'd run it without them. They look great. It's the same chocolate cover. You know, these cages were pretty beat up, so the guy that did them did the best job straightening them he could. They're not perfect, but I think they look pretty darn good. And as you can see, that nice chocolate brown color. And I think we've got one thing left to do here, but you know what? I may let the customer do this. I've got the Mark III labels that would go on the face of this thing, and I may just let the customer decide where to put those, where they want them on there. You peel off and adhese them and stick them on. But I'm going to power back up with the cage, just make sure there's no issues from the screws mounting in or anything all the way around. Make sure this thing's still playing well. Okay, all plugged up here, as you can see. Looking great. Let's see how it sounds. I think it sounds great. I'm going to do two things. One, we're going to get the cage back off of this, flip it upside down, build the other one tomorrow, mimic this one basically, test it out. Once I've got both of them going, I want to get them over on my audio bench over here, and I like to play them for a week solid. I really, after building something like this, I really like some good burn-in time, just to make sure nothing crops up before I send something back to the customer. But we're going to call this thing a wrap for the day. It's sounding really good, and couldn't be happier.
Unicorn up her shoulder.
Alright, thanks everybody for watching. Finally got this thing to life. Hopefully through the series you've learned a little something. I always do. I've built probably 15, 20 Dynaco kits in the past. Built many other kits, and yet still every time I do one, I try to improve something. I learn a little something, do something a little different. But really happy with how this thing turned out. I think it's going to make the customer great amps for years to come. Thanks again, everybody.